So what we've developed is an activity planner that be assessed and looked at as we're at the beginning of the design process. Let's have a look at two examples of the activity planner. Here you can see the different types of activities that I explained earlier. In this course, we have a wide range of activities. And most of the work that the students are doing is classed as experiential, very hands-on activity. 20% is assessment, and we can see communication is important as well as assimilative tasks. If we look at the module below, here we've very little going on in communication, finding and handling information, no experiential or interactive and adaptive work. Of course, there's assessment to find out how the students are doing. The activity is reading and looking at different types of information. What are the implications? We find the workload is too high in this area. The students are not so engaged as they are with this type of design. And so this is how, when we start the courses, designing the courses, we're looking at the types of activities that can stimulate, support our students. So we have a learning design plan with recommendations and actions to meet the design challenge, manage the risks, and explore the opportunities available with the technologies, with what we know from our research, into a new module. Then we move into the production phase, building the course and testing it, looking at student workload. We might redesign some of that with the workload. When we move into the first presentation, as these modules run for 8 years, there is an evaluation, and we change things. But also we train the course team, the module team, to use the analytics that we have on board. And we identify case studies and reflect on what we've done and pass that information on to the next group that we're going to work with. So let me show you an example of an evaluation of something that we did in one of our courses. We have 2 presentations a year, a B presentation and a J presentation. And in 2018, there was a problem with, it was a software development course with software activities. The module team identified an activity in week 6 that needed to be updated, because if you look at 18B, this brown line here, problem here with a lack of activity that was needed. They changed the activities and moved the load. So we see in the next presentation an increase in activity, which also affected the TMA scores as well. So the students did better. So understanding what we did, it wasn't working so well, making that change and illustrating the difference. Also, workload is very important. If the students have too much work to do, they're not going to do so well. They're going to drop out. Now, after the students have completed every module, we give them a questionnaire. We call it the SEAM questionnaire. Here are the questions from that questionnaire. And with this particular course, we found that the student workload, the students complained the workload was too high. This is this line here. And after changing the course, response rate changed. The students were more satisfied, and we got a change there. So we got a change in the workload, and also we had a change in satisfaction. We were less satisfied when the workload was too high. We made the changes, and here you can see in the next presentation the difference. So the learning design is also about evaluating, learning from that, and what makes a difference so that can be passed on to the other teams as they move forward in new productions. Now, we've also introduced what we call predictive learning analytics since 2013, which I'm going to talk about next. We've had the learning design with us since 2005. And what we're going to do and are working towards is this integrated learning analytics. This is the future for us with the introduction of more AI into our courses. So that's what I'm going to talk about next, is the predictive learning analytics that we're using. Now, we've always had analytics, conventional modeling. We've been doing that since the start of the university. We're using regression analysis and looking at our data, our stats, our retention probabilities, designing those from our regression analysis, understanding the success variables. But what we've recently introduced is machine learning, where we look at the assessment as well, the assessment submissions, and what we have produced from all this data together is a recommender system, which I'm going to talk about. So what does this system do? We're calling this the early alert indicators. And we have OU Analyze, which makes, with machine learning, short-term predictions about whether the students will submit their assignments. And we also have student probabilities, that sort of modeling where long-term predictions of completing and passing a course is calculated based on the regression analysis. So together, we can produce predictions as to whether students are at risk of failing their studies. And when we have OU Analyze on its own with the machine learning, it predicts on a weekly basis whether or not a given student will submit their next course assignment. And this uses a traffic light system to pinpoint in red students who are at risk. This is the traffic light system here, and we can see this student is at risk. And how do we predict that? That's from the activity that's going on in the VLE, in the Moodle. So the blue line is the course average activity for all the students. Yellow line here is that of the student themselves. So where there is little activity at assignments, where they've not put in an assignment, we can start to see what's going on. So here's our traffic light system. These two students are pulled up as being at risk. This will come to their tutors. And here we can see, the column here is risk of non-submission. Short-term predictions are being taken from their activity. And the feedback being given to the tutors for week 5. So these students are unlikely to pass, to give in their assignment, not as great as the likelihood as these here, and long-term predictions for completing the course and passing the course. And of course, these numbers change as these students are further into the course. So here's an example, as I said before, average activity for the students online, engaging with their coursework. And this particular student not engaging at all, and picking up into week 9. Some activity down again week 11, up for week 12, down again 13, 14, and the is below that of course of the cohort, and these are the different areas. This is the first part of the course, the second part, third part, and this translates into the TMA predictions, the assignment predictions and scores, and the long-term predictions that the teachers can look at as the students are moving through. So here is the data that we use to predict risk. We have static data, data that we already know and isn't changing per se. So the age, ethnicity, gender, highest education, occupation, etc. We have pre-course results from their previous assessments, previous passes and failures, numbers of credits. So that's static. But then we have this data that we use that will be changing as the students are moving through the module and the course. So we have the assessment scores as they come in, their activity on Moodle, the VLE data, and linking to the qualification of the student. So all this data is being used to make predictions. Now, here's some work that we did, because we had to start somewhere, and how we gave access to the team to this OU Analyze, and then how they used and accessed the data. You can see that over from 15 to 2018, we've got an increase in access. However, we don't get the same increase in activity, use of the system. So what are we going to do about that? We've looked at this since in the different faculties. We have 4 major faculties: business and law, education, science, and social science. And we looked at the teachers, the course chairs. They're the academics who run the academics in the team and the production, and some presentation, and all staff. And what happened? What did we find? The things and the factors that are very critical are the faculty's engagement. And to increase the engagement, we had champions, teachers champions, who'd worked well, would encourage others to use it, show very clearly the evidence generation and dissemination and how important that is, and the discussions about teaching online. So the big question is, we spent all this time building these systems, getting our data together to do this with our machine learning, does lead to better student performance. On this paper here, the lead author is Christothea Haradutu, who works in the Institute of Education and Technology, part of my team. We can see here that the best previous score and the use of OpenAnalyze makes a difference and is a good predictor of student pass and completion rates.
Thank you, Professor Whitelock.